So hello, welcome back. In this video we will see another important topic known as momentum and its units and its relation with Newton's second law of motion. Then we will see what is impulse, and then we will use one example 3.2, which is the explanation of this topic. So first we will see what is momentum. We are aware of the fact that moving object possesses a quality by virtue of which it exerts a force on anything that tries to stop it. The faster the object is traveling, the harder it is to stop it. Similarly, if two objects move with the same direction and same velocity, then it is more difficult to stop the massive of two. So here we will see definition of linear momentum. This quality of moving object was called the quantity of motion of a body. Quantity of motion of a body by Newton. The term is now called linear momentum. Linear momentum is defined as P is equal to m cross v. If the expression v is the velocity of mass m, linear momentum is therefore a vector quantity and has direction of velocity. Mass is scalar and v is vector. Velocity is vector, so it is a vector quantity. The SI units of momentum is kilogram meter per second, kg meters per second, or it can also be expressed as Newton seconds. Now we will see momentum and Newton's second law of motion relation. Consider a body of mass m with a velocity vi, initial velocity vi. If an external force F acts upon the body after a time interval t, which becomes Vf. The acceleration, we always know that A is equal to Vf minus Vi is equal to At, and we have derived this relation from this equation. Vi plus A into T. So from this relation, separating values of A is equal to Vf minus Vi over T, and from Newton's second law of motion, F is equal to ma and A is equal to F over m. Equalizing this equation number 1 and this equation number 2, we get F over m is equal to Vf minus Vi over T. Multiplying or cross multiplication gives us F is equal to F cross T is equal to mvf minus mva. M is the common quantity, mvi is the initial linear momentum, and mvf is the final momentum of the body. So from equation, force is equal to mvf minus mvi over t. The second law of motion can also be stated. Now Newton's second law of motion is follows: time rate of change of momentum of a body equals to applied force. This is the definition of Newton's second law of motion in terms of momentum. Now we will see another topic in this video, which is impulse. Impulse is the byproduct of momentum. Sometimes we wish to apply the concept of momentum to cases where the applied forces is not constant. It acts for every short time. For example, when a ball hits a cricket ball, the force certainly varies from instant to instant during the collision. In such cases, it is more convenient to deal with the product of force and time F cross T instead of either quantity alone. This F cross T is also called impulse of force, and F can be regarded as the average force that acts during the time T. Impulse, we can define F cross T is equal to mvf minus mva, which we have already seen in this relation. Simply we have multiplied F cross T, which gives us the value of impulse. Now we will see this example in which a body of 15 kg weight having a velocity from 20 to 15 meter per second in time t. How large was the average retarding force? So retarding force is actually the impulse. We will write mvf, we will write mvi, then we will multiply with time. So we know that F cross T from above relation is equal to mvf minus mvi. Putting the value of time t, mass with initial momentum and final momentum. We will find the value of force, which is equal to minus 2.5 kilonewton. The negative sign indicates that the force is the retarding force. So this is a very important information. Do you know your hair acts like a crumple zone on your skull? A force of 5 Newton might be enough to fracture your naked skull, known as cranium, but with a covering of skin and hair, a force of 50 Newton would be needed. So in our next video we will see what is the law of conservation of momentum, and its one example 3.3. That's all from this video. Thank you for watching.